Hey guys, Mr. Babbitt here with a video for you talking about the unit circle. We've been working with this stuff in Unit 13 and you didn't really know where it was coming from, but I think today it'll all kind of come together and you'll better understand where we're getting this information from. So little recall section here. We're looking at 3 different sizes of triangles. All of them are right triangles. You can see in this first one, the smallest angle right here, since we're talking about special right triangles, this would be 30, there's our 90, and this would be our 60. So when it comes to labeling, our hypotenuse is always 1. Across from the 30 would be 1/2, and then across from the 60 would be the square root of 3 over 2, right? So we talked about this a little bit in the last unit. This next one, you can see both of these sides are the exact same length. So when that's the case, you have a 45, 45, 90 triangle. So 45 degrees and 45 degrees there. So the way that we would label our triangle for this one, our hypotenuse is 1. And then the sides are root 2 over 2 and root 2 over 2. And then this last one, just like the 30, 60, 90 in the first problem, you can see that now this is going to be the 30 and this will be the 60. So it's just kind of changing the positions up. Hypotenuse of 1 across from the 60s, root 3 over 2. And then the 1/2 would go right there. All right, so labeling the degrees of the unit circle. So we've talked about this before. We got 0, we got 90, we got 180 right here. We get 270, and then if we make it all the way back around, that's 360 degrees. Right, so in each quadrant, right, we have quadrant 1 right here. Here's 1, here's 2, here's 3, and here's 4. So if you hear me refer to it as quadrants, that's what I'm talking about. In each quadrant, you're going to have 3 angles. Okay, the first one here, this is going to be our 30-degree angle. This next one here will be 45 degrees, and then this one will be 60 degrees. Right, and so it's always going to be in terms of like 30, 45, and 60, meaning now that we're at 90 to get to our next one, we just do 90 plus 30, and so now we're here at 120, right? And then we do 90 plus 45, and that gets us to 135 right there. And then we do 90 plus 60 to get us to 150. Okay, and so that's how we're going to get those measures right there, and we'll talk a little bit later about how this creates a reference angle right here, right? So our reference angle from 180 to 150 would be 30, and we've talked about that in the past, okay? As we continue on, you can just add 30 to 180 degrees, and that'll give us 210. After that, you do 180 plus 45, that gets you 225 degrees. And then the last one in this quadrant, 180 plus 60, will get you to 240 right there. So it's always those same kind of 30, 45, 60 angles, because that's how we can draw our right triangles. Down here at 270, we add 30 to that, we're at 300. Add 45, we got 315. And then if we add 30 to that, or 60, I'm sorry, to 270, you get 330 degrees. And now we're all the way back around. All right, so we'll continue working with this, but it's important to at least understand kind of where we're getting those angles from. And seeing that we have 3 of each angle, 3 angles per quadrant here, okay? On to the radians. So we've talked a little bit about this. We were drawing our circles. We were splitting it into different sections, right? There would be 3 sections right there, 4 and 5. So now we would have 6 sections, 1, 2, 3, 4, 5, and 6. So that would be pi over 3, because we're splitting the top into 3 parts like this, right? That's how we would split it for pi over 3. Now, what we're going to see here is we're going to kind of put all of those together. The pi over 3s, the pi over 4s, and the pi over 6s are all going to be on one unit circle. So I'll use different colors to kind of help us identify what we got going on here. Of course, I can use black here, we got 0 here, we got pi over on this side, and then if we make it all the way around here, we got 2 pi, right? So the easy ones are called the quadrantal angles, so that's the ones kind of straight up and down, so like right here up top, and then on the sides and on the bottom. So if 0 starts over here on the right, and then pi is over here on the left, well then halfway would be 1/2 pi, or we would say pi over 2. Okay, we didn't use that a whole lot in Unit 13, but we are going to use it in this unit. And then down here at the bottom, this would be 1.5 pi to get down here to our bottom angle here. And 1.5 pi, the way that we would write that is we would just say 3 pi over 2, because 3 over 2 is the same thing as 1/2. All right, so similar to the degrees in each quadrant, we're going to have 3 angles. Okay, this first one is going to be pi over 6 right there. The next one will be pi over 4. And then our final one right here will be pi over 3. Okay, so we got 6, 4, and then 3 in that order. Okay, and then on the other side here, as we continue, it's going to kind of go in reverse order. So this one right here will be 2 pi over 3. This next one will be 3 pi over 4. And then the one after that, this will be 5 pi over 6. Now you might be wondering, you know, if pi over 6 is right here, where's 2 pi over 6? Well, that's the same thing right here as pi over 3. This is just 2 pi over 6, right? Because if you divide both of those by 2 to reduce it, you end up with pi over 3, okay? Similarly over here, instead of 4 pi over 6, right, 4 pi over 6, that just becomes 2 pi over 3. So we can reduce all of, we can reduce 2 pi over 6 and 4 pi over 6, and that's how we're getting these pi over 3 marks, okay? So let me erase that real quick. And that's how we would continue all the way around the rest of our unit circle. So after this one right here, at pi, you know, this is 6 pi over 6 or 3 pi over 3 or whatever it is. So this next one would be 7 pi over 6. After the 6 comes the 4. Remember, the 4 is always going to be right down the middle, right? Because we've talked about that. It's splitting it right down the middle because it's 45 degrees. So this is going to be 5 pi over 4. The next one would be 4 pi over 3. And then that brings us to 3 pi over 2. And then again, we go in reverse order here. So now we're on to the pi over 3s again. So this is 5 pi over 3. The green one, our 45-degree angle, cuts it perfectly in half. So that's going to give me 7 pi over 4. And then our last one is the pi over 6s. So this is going to be 11 pi over 6. Because all the way back around would be 12 pi over 6. 12 divided by 6 gives us 2. All right, so that's how we got that there. I think an easy way to remember it for sure is you can get the green ones because you know those are the pi over 4s. It cuts them perfectly in half every time, right? So it's that right there, those 4 angles right there. And then the 6s are going to be the ones closest to the x-axis, right? Because we've talked about this. This reference angle here would be 30, so they're going to have the smallest distance away from the x-axis. And then the pi over 3s are up towards the top. All right, and so that your homework tonight will just be filling out this entire unit circle using degrees and radians. So hopefully that won't be too bad for you, okay? Now, the last thing that we're going to do here is labeling the coordinate points. Coordinates, of course, meaning like an x comma y, something like that. What we're going to see here is that our x value represents cosine and our y value represents sine, as it says, you know, right up above, right here. Okay. So the reason that this is if you think about our right triangles that we were doing with in our last unit here. Let me see if I can draw this easy. Perfect. When we were doing this in our last unit, we always said the hypotenuse was 1. This is, you know, our x value, and this is our y. So we have our reference angle down here in the corner. When we label our sides, here's our opposite, adjacent, and hypotenuse. Now, what you might have noticed is that when you're finding the sine of your angle, right? So if we were doing like sine of 30, we're going to do our opposite over hypotenuse, right? This is O over H for sine. When you do that, you're going to end up with y over 1, right? Well, anything divided by 1 is just itself. So now we're going to get that the sine of theta is equal to y, which is exactly what we're seeing right here, right? So because your hypotenuse is 1, it's not going to change the value when you divide by it. Okay, and then you can see that exact same thing if I change colors here real quick. When we do the cosine of theta, that's, of course, adjacent over hypotenuse, right? Adjacent over hypotenuse. So that's going to be x over, and then my hypotenuse is 1. Well, again, anything divided by 1 is just itself. So cosine of theta equals x. And then right up here, we can see cosine of theta equals x there. Okay, so our x is going to represent cosine. Y is going to represent sine. And then tangent, when we're finding the tangent of it, you're just going to do the sine divided by cosine. Okay, and we'll talk more about that going forward as well. So if we take a look here, this triangle is going to get kind of busy, so try and stay as organized as you can here. But we know that this first one right here, this is 30 degrees, right? This is 30 degrees. And so when we drop our altitude here, okay, we know this is 30 degrees. We know the hypotenuse is 1. Of course, we know this is a right triangle. Across from the 30 is 1/2, which makes this one root 3 over 2. Right, and so if we were writing the coordinate point for this one, I'll write it in, how about let's do, I don't know, green. The way that you would write this is, of course, x comma y. Well, my x coordinate is just this bottom one right here. So we got root 3 over 2, and then my y is just my height. So that's going to be 1/2. Okay. If we do the next one, again, let's maybe use a different color so it's easier to see here. Or I'll just erase it. How about that? I just erase this triangle. And if we relabel the next one, I'll give you a second to erase that if you want. Or you can kind of just follow along here. If you draw your amplitude from here down, right, this is our 45-degree angle, of course, right, because it cuts it perfectly in half, this quadrant. So our hypotenuse is 1 again. And then across from the 45 here is root 2 over 2. And then this would be root 2 over 2 as well, right? And so what you're going to get as your coordinate point here is your x value is this one. So square root of 2 over 2. And then your y coordinate is your up and down. So root 2 over 2. Okay. Cool. And then this last one, if you want to just follow along, you don't necessarily need to draw it, but I want to draw it out to kind of help you visualize what we got going on here. This last angle up here is this 60-degree angle, right? Because we go 30 here, 45 here, and then the last one would be 60. So when we draw our amplitude down, we got a right angle, we got a 60-degree angle there. Well, we've gotten used to labeling these by now. Our hypotenuse is 1. Across from the 60 is the square root of 3 over 2. And that makes this one 1/2. So now when you're writing your x, y coordinate, your x is the bottom here. So that's going to be 1/2. And then your y value would be the up and down, which would be the square root of 3 over 2. Okay. And so, you know, as we've talked about in the past, if you take a look over here, this one right here is the exact same as this, just in different positions. You know, as we've talked about with the 30, 60, 90 triangles, it's always root 3 over 2 and 1/2. It's just figuring out which position it's in. Okay. So if you look at this, the root 2 over 2, root 2 over 2, those go together. So that's fairly easy. And then these ones are just flipping positions there. Okay. One more thing to note here. Would be that this quadrant, if you look right here, you're going to have positive x's and you're going to have positive y's because we're going to the right and we're going up. So both of these numbers are always going to be positive in this quadrant. Okay. over here in this quadrant, in the second quadrant, your x's are going to be negative, right? Because we're going to the left, and then our y's will be positive. Down here on the bottom left, well, we're going to the left and we're going down, right? So left and down are both negative, so we'll have a negative x and a negative y. And then this last section down here, this is going to be positive x's and negative y's. Okay, and so that'll stay consistent. And as we draw these, you know, it won't be too bad for us. Okay, okay. So let's go ahead and label the rest of these quadrants. You're going to see that it's the exact same as quadrant 1, right? So if you can do quadrant 1, you can do the rest of them. The positives and the negatives are just going to change a little bit, right? So I'll show you this real quick. But this, of course, would be our 60-degree angle, right? Because we're 60 degrees away from the x-axis, our reference angle. So when that is 60, then this will be root 3 over 2, and this will be 1/2. So then our coordinate point would be, well, this is negative, right? Because it's going to the left. So this would be negative 1/2, and then square root of 3 over 2. Well, which one does that match up with? The top one right here. Okay, so those just flip positives and negatives. And as do the rest of these. So this one down the middle, let me go ahead and clean this up a little bit, make it a little nicer. This one down the middle is our pi over 4. So this, our x's are negative here, negative root 2 over 2, and then positive root 2 over 2. And then this last one matches with this over here, right? Because this is always the case when we have a 30-degree reference angle. And of course, right here we have a 30-degree reference angle. So this is going to be root 3 over 2, negative, right? Negative root 3 over 2, comma, 1/2 is what we would end up with right there. Negative right there. Okay, let me, struggling with this iPad. Let's see, 1/2 right there. Okay, and then let's keep going. So down here in this quadrant, they're both going to be negative. So I like doing the 45 first. So you got negative root 2 over 2, negative root 2 over 2. This one closest is your 30-degree reference angle, as we just did. So then this is going to be, whoops, sorry, that should be negative right there. We would have a negative root 3 over 2, and now our y is also going to be negative, right? So x's and y's negative, as we wrote down here. And then this one would be your 60-degree reference angle. If you dropped your amplitude or altitude, I can never figure out which. And so this will flip. So we'll have 1/2, negative 1/2, comma, negative root 3 over 2 right there. Okay. Over here to the last quadrant, just about done here, folks. This one matches up with this. So we're going to have 1/2 and then a negative root 3 over 2. The reason the 1/2 is positive is because now we're going to the right. We're going to the right to get your x value and then down, so that's why the y is negative. Okay. Next one would be square root of 2 over 2, and then a negative square root 2 over 2. And then this last one is going to match with this one right here. So we got square root of 3 over 2, and then negative 1/2. Okay, so again, if you can get the first quadrant, you can get the rest of these, because these are just based off of your reference angles. Okay, so you can make a note, based off of reference angles. All right, so hopefully that doesn't feel like it's coming completely out of nowhere, because we have been doing, some stuff with these types of numbers. Okay, final thing that I want to talk about real quick is, let me change my color here, our quadrantal angles, which are these ones up here, right? This one right here, this one right here, this one right here, and this one right here. So if you think of the center here as your origin, or like 0, 0, right? You don't need to write that. I apologize. I should have said that. What we end up with here is, since we went to the right one to get to this point, and then we didn't go up or down, our coordinate here would just be an x of 1 and a y of 0. Okay, x of 1 and a y of 0. This one up top here, right? We didn't go left or right, so our x-coordinate would be 0, and then our y value would be 1. And the reason it's 1 is because if you think about it, our radius right here is always 1, because the distance to the outside of the circle, your radius is 1, okay? This one over here, you'd end up with, -1 comma 0, and then you might have figured this last one out down here. You got 0 comma -1 there, okay? You have this unit circle back here. You're also going to get a unit circle as part of your homework. It's got some hints down here, right, that can help you out with certain things. But what I would hope is that with help of your notes or the people around you, that you can fill out all of these points, right? So I'll just show you the first quadrant. What I'm looking for is something like this. We need to see 0 degrees, 30 degrees, 45 degrees, 60 degrees, and then up top here would be 90 degrees. And then we would go through and we would do all the radians. So this one right here would be pi over 6. This one right here would be pi over 4. This would be pi over 3. And then this one would be pi over 2. And then the last thing that we would do in each section is our coordinate points. So we got 1 comma 0. 1 comma 0. This one right here is going to be square root of 3 over 2 and then 1/2. And of course, if you need to draw that reference triangle until you memorize it, absolutely. Draw it and label it real quick. The 45s is the easy one, right? So this is square root of 2 over 2 and then square root 2 over 2. The 60 is just this one down here for the 30, but flipped. So the 1/2 will be our x, and then the root 3 over 2 will be our y. And then up here, we have the coordinate 0 comma 1. Okay, so you'll go around and you'll do that for all of these points here. I would start by doing all of the degrees and then all the radians, but if you want to go coordinate by coordinate or quadrant by quadrant, I think that would also work out for you. All right, I'll be back tomorrow to help